terbaik sebagai karya baktimu. Teruslah berjuang membangun Indonesia, sejahterakanlah bangsa dan negara. PII Persatuan Insinyur Indonesia. Insinyur Indonesia senantiasa menjunjung tinggi integritasnya, bekerja sungguh-sungguh dengan semangat profesionalismenya, utamakan keluhuran budi, amalkan ilmu dengan kompetensi, berikan yang terbaik, selalu yang terbaik sebagai karya baktimu. Teruslah berjuang membangun Indonesia, sejahterakanlah bangsa dan negara. Teruslah berjuang membangun Indonesia, sejahterakanlah bangsa dan negara. PII Persatuan Insinyur Indonesia.
Okay, so let's just start the opening ceremony of the webinar ya. Pak Imam, you ready? Pak Imam siapa?
Siap,
Jadi ya acara pertamanya kita menyanyikan lagu Indonesia Raya, singing the national anthem of Indonesia, Indonesia Raya, and then continue with himne PII ya, singing himne PII, and then we have Pak Dr. Mulia here, mungkin akan memberikan dua patah kata sebelum Pak Danis, Pak. Nanti kita persilahkan ya. Ya silakan Pak Imam.
Insinyur Indonesia berbudi luhur dan berintegritas, kompeten dan profesional, bertanggung jawab sepenuh hati. Kami Insinyur Indonesia, kami menerangi negeri, mempersatukan Nusantara, membuka cakrawala dunia. Kami Insinyur Indonesia, kami memajukan bangsa, mensejahterakan masyarakat untuk kemanusiaan semesta alam. Kami Insinyur Indonesia, siap membangun bangsa.
Okay, yeah, thank you, Mas Imam. Okay, I will continue to second agenda. So will we have opening remarks, yeah, by Chairman of PII Province Kepri, Dr. Insinyur Mulia Pamadi, IPU ASEAN TPA. So Pak Mulia, please give us one or two speech including a pantun. Thank you, Pak.
Maaf, belum ada persiapan pantun. Okay, yeah, Excellency, our Vice Chairman, Mr. Danish Hidayat Sumadilaga, our speaker, Your Excellency, our speaker from Australia, Nia Gan, and from Singapore, Ling Yi Tiong. And also our panelists, Pak Andi Sanjaya dan Pak Habibi Rasa. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and wish all of you all the best. We are very happy today we can join together for this webinar, and we hope this webinar can bring us the knowledge for the higher speeding. And we also thank you to Mr. Habib Rajak, always give us the opportunity from PW, PI, and PCPI to have to hold the webinar. Okay, I just give a short sambutan. So I close my pronouns by one of the pantun, makan durian bersama kesasi. Cukup sekian, terima kasih.
Terima kasih, Pak.
Yeah, thank you, Pak Dr. Mulia Pamadi, as Chairman Decision of Engineer Indonesia, we call chapter Kepri or Province Kepri. So for the next agenda, we will waiting the Vice President of PII, Pak Dani Sumadilaga, because he will join us around 1:30. So because today Pak Habibie also as a panelist and moderator, so maybe Pak Habibie can give us a portfolio or biography about our speaker. Thank you, Pak Habibie. Please.
Thank you, Pak Prastiwo. I think the right man who is going to introduce these both speakers will be Pak Andi Chong ya. Pak Andi Chong actually our engineer who initiated this this webinar. Maybe Pak Andi, would you like to introduce before we ask Pak Danis Sumadilaga to present the opening remarks once he arrives in this event. Thank you, Pak. Still mute, Pak. Masih mute.
Okay, give me 1 minute, Pak Habibie. Let me take some of the introduction. Okay, so maybe let me introduce both speakers, which is Nilgan and Itiong. So the first one, Nilgan. Nilgan is the regional manager of BGNE in charge for Southeast Asia. Neil is a chartered professional engineer who has over 18 years experience as a structural engineer with a focus on delivery of technical, challenging and innovative design solutions. Neil's career spans across Australia, Europe, Middle East, and Asia, and he has played a key role in the establishment and growth of both the BGNE Singapore and Perth offices. Neil has significant multidisciplinary experience, including high-rise, commercial, retail centers, life science, and heritage development. Neil has experience in leading design and construction engineering teams on large-scale, complex, and high-profile projects. Neil has a proven track record of delivering design solutions which represent cost-effective and really buildable structures applying best international standards and practices. Neil is an active member in Engineers Australia as well. So the next one is for Itiong Lim. Itiong is the studio director of Gensler Singapore. Is a UK registered architect, has over 20 years experience in London, Hong Kong, and Singapore. He delivered large-scale architecture and master planning design projects in Europe, Middle East, and Asia Pacific. Many involve complex design, programming, and management challenges. He specialized in office, mixed-use, transport-oriented developments, super high-rise projects, and master planning developments, having led and successfully delivered many prestigious projects in Asia Pacific. He is actively involved in the building industry as RIBA Singapore third chairman, active participant of ULI initiatives, and sharing his experience as speaker and panelist at built environment conferences. Yeah, so those two are the introduction of both speakers.
Thank you, Andy.
Yeah, thank you, Pak Andi Chong. So we have one engineer and one architect, yeah. And if I'm not mistaken, both of them are based in Singapore.
That's right, yeah.
Okay,
Yep,
thank
that's
you,
right.
Pak Andi. In my screen, we already have Pak Danis Sumadilaga, our Vice Chairman of the Institution of Engineers Indonesia. I think we can start the opening remarks by Pak Danis. Pak Danis, time is yours, Pak. Thank you.
Okay. Good afternoon, my dear friend, distinguished speaker, presenter, expert, Pak Habibie. It's a very good afternoon. It's my pleasure to join all of you here in this webinar, yeah, on behalf of the Institution of Engineers Indonesia, and also my appreciation to the organizing committee, Pak Prastimo, yeah, and others, yeah, especially from the Institution of Engineers Indonesia of Batam and Kepulauan Riau for arranging this webinar amidst the COVID-19 situation. So I understand that today all of us will have two great speakers. Yeah, as explained before, the CV Neil Gunn. Gunn or Gun? Gunn. Yeah.
Gun, that's right, yeah.
Gunn, okay, who will share his experience in new technology for high-rise building and showing case study in Australia and Dubai, yeah,
That's
about
correct.
iconic building by Hadid, yeah, and also regeneration project. Also, the second speaker is my friend Lim E. Tiong, yeah, an architect, who will share a topic, create community in vertical cities. Okay, since you are both already talking about the very specific in high-rise building, please allow me to convey several things. Yeah, I believe that this event will be very important for us. Yeah, allowing us to opportunity to share experiences, challenges, innovation, information toward better development for high-rise building in Indonesia. First, I'd like to convey number one. Yeah. In Indonesia, urbanization is growing rapidly. Yeah. It's related to the high-rise building later, yeah. Currently, 52% of population living in urban area, and it is predicted rising to 65% in 2025 and 70% in 2035. What does it mean? Yeah? It means that most of it is undeniable that the city is required to be developed continuously. Yeah, with this urbanization. The inadequate land size and the increasing number of city dwellers will be a serious threat to sustainable urban growth in the future. Without comprehensive and sustainable urban planning, it will lead us to a kind of degradation of city service quality. Buildings are required to accommodate the human need for space, what we are talking today. Yeah. High-rise building is a solution, one of solutions to fulfill human needs for space to answer the challenge and the inadequate of land. Right? Another thing is the climate change. Actually, I prefer to say climate crisis. Yeah. Climate crisis is also one of the biggest challenges we are currently facing and impacted on many aspects in life, no exception for building design and function. But which is our topic today. Yeah? One part of life that is affected by climate change is high-rise building and residential houses. This will put the planning for residential or building development on a complex challenge. Let me explain more in terms of SDGs. Infrastructure development has important role to achieve sustainable development goals, yeah? Particularly Goal 19, Sustainable City Settlement, and Goal 13, Climate Action. Moreover, the infrastructure also closely related to four main sectors: energy, land use, transportation, and building, which are contributing to greenhouse gas emissions. In brief, enhancing the infrastructure deliverability process has significant contribution to climate change in action. Yeah. Ladies and gentlemen, yeah, I was in the Ministry of Public Works before. So during my period in Ministry of Public Works, the strategy of infrastructure development has put sustainable development in the first place. One of the strategies to increase the utilization of local material and tools in order to create added value to every infrastructure. This strategy will reduce carbon footprint and contribute to climate action. Yeah. And also, I like to specifically, yeah, especially to my friend in Indonesia, about Government Regulation 16 of 2021 concerning implementing regulation of law 28 of 2002 concerning buildings. It regulates the building reliability, which include the aspect of safety, health, comfort, and convenience of building. I hope that we are talking about this later. Yeah, aspect, yeah, safety, health, comfort, and convenience of building, since it's already put in the government regulation number 16 of 2021. Furthermore, it is regulated in Article 9, which stipulates that classification of building based on the heights of the building is translated into super tall buildings. This is our regulation in Indonesia. Skyscrapers, high-rise building, medium-rise building, and low-rise building. It is further explained in the appendix that a high-rise building is a building of 8 to 40 floors. A skyscraper is 41 to 100 floors, and super tall building, super tall is more than 100 floors. So, various kind of high-rise building innovation can develop rapidly. I believe that this is something that will explain, especially maybe by Neil Gunn, yeah, maybe, yeah. Starting from the planning to the construction process. I hope that technology encourages efficiency in the process of construction high-rise building. That is the first criteria, efficiency in the construction of high-rise building. In the innovation that continue to develop, there are guidelines as a technical reference in the construction of high-rise building. In Indonesia, we have Indonesian National Standard or SNI, Bapak Ibu sekalian, ya, yang harus merefer, ya. That regulates all aspects of architecture, structure, mechanical, in order to achieve quality of the buildings. And not less important in the construction of high-rise building, I like also to mention about the security. Security also the important aspect. Building fire protection, both active and passive security protection is very important. And I understand that fire protection technology continue to develop dynamically within the times. Also, in the planning process, yeah, I started the development of building information system technology, BIM, yeah, can make the construction process more efficient. We have already applied in several buildings, yeah, in Indonesia, this BIM. So it makes us faster execution time, easier stage monitoring and evaluation process, and so on and so on. BIM. The use of BIM application is also regulated in Government Regulation 16. In Appendix 3, yeah, for medium and high-rise building, it is mandatory to use BIM up to the 5th dimension, and for skyscraper, it's mandatory to use BIM up to the 8th dimension, yeah, model 8. In addition to implementing the use of BIM, the implementation of the green building policy in Indonesia has an obligation to build sustainable, which is regulated to regulation in the Ministry Regulation number 21 of 2021, number 21 of 2021 concerning green building performance assessment. What is going to be assessed? Yeah. I think that is already explained. Yeah, several buildings that already implemented in the concept. For instance, the main building of the ministry has received Paris Green Building Award. Jadi Bapak Ibu sekalian, dalam regulasi itu kita bicara juga yang green building, kriteria itu dalam aspek-aspek ini. So. And other things, the development of high-rise building in Indonesia is facing the challenge of Indonesia geographical condition. As we know, Indonesia is an archipelagic country located at the confluence of 4 tectonic plates, namely the Asian continent plate, Australian, Indian, and the Pacific Ocean. And also, in the southern and eastern part of Indonesia, there is a volcanic arc that makes Indonesia one of the countries that has a high level of seismicity. So I like to remind that about the seismicity in Indonesia. Yeah. So in the development of the high-rise building, of course, innovation are needed that still take this risk into account. Please take this into account in your planning so that reliable and sustainable high-rise building can be achieved. So, ladies and gentlemen, I'd like to again extend my gratitude toward my fellow engineer for their contribution to build Indonesia toward modern and innovative development. And last but not least, I wish that this event will provide space for collaborative participation and strengthen commitment, as I believe that is the key for the sustainability of our built environment. Thank you.
Thank you for the opening speech, Pak Danis. There are several bullet points which has been passed by Pak Danis, our Vice Chairman, which will be the chairman in this coming December, because we are going to have a Congress. Pak Danis will step up from the Vice Chairman to become a chairman for the next period from 2021 to 2024. So some bullet points would like to mention to everyone. I think this will be a basis for both speakers to discuss, to present as well later on. I think the first one is more on the need of the high-rise buildings in Indonesia as the development of the urbanization, more spaces needed in big capital cities such as Jakarta and other cities in Indonesia. Pak Danis also mentioned the sustainable development goals, which is related to energy, land use, and buildings. We need to make sure that the buildings designed according to SDG, according to the climate crisis, as mentioned. That Pak Danis also mentioned about the regulation, several regulations related to building design, which should comply to Indonesian standard, should be safe, healthy, comfort and convenience, something like that. And the category of the buildings, super tall, skyscraper, high-rise, and low-rise building also mentioned. And last but not least, also Pak Danis mentioned about the application of building information modeling. I think it is mandatory now for high-rise buildings to use the building information modeling as a platform to get faster execution on the design, construction, as well as operation and maintenance period. Okay, thank you, Pak Danis. Let's start with the first.
Thank you. Have a nice discussion. Congratulations.
Terima kasih, Pak.
Yeah, thank you, Pak Danis.
Thank you.
Okay,
Please.
let's start with Neil Gunn, as the first speaker.
Thanks,
Neil,
Bibi. I'm just going to share my screen here. If you can let me know when you can see it.
Yeah, we all can see it.
Great. And you can hear me clearly as well, can you?
Yes.
Fantastic. Okay, well, first of all, it's a pleasure to be here this afternoon, and thank you to the Institution of Engineers Indonesia, Riau and Batam branch, for the opportunity here to share some of BGNI's experience on this topic. We hope you find it enjoyable and interesting. My name is Neil Gunn. I'm the Regional Manager for Southeast Asia, based here in Singapore. And I've over 18 years experience working across Australia, Europe, Middle East and Asia. And I've been fortunate enough in that time to have led design and construction engineering teams for BGNI on some large scale and complex and high profile projects. So BG&E, I'll tell you a little bit about BG&E first before we start going through some of the case studies. BG&E celebrated its 50th year of operation this year. It's originally an Australian practice that begun in Perth. Today, we've got over 700 staff across 12 international offices. We're 100% employee owned. And relevant today, I suppose, we're also ranked in the top 10 of the world's tallest engineering designers with the Council of Tall Building and Urban Habitat. Our global footprint stretches from New Zealand through Southeast Asia, through the Middle East, where we have a huge amount of our high-rise experience, and through Europe and our London office, which services our European-based projects. What BG&E do? So we're a civil and structural consultancy service. So we work in the spaces in infrastructure, building structures, facades, bridge works, industrials, and material innovation as well. And our innovation and our continual improvement are the core of what we do. So we have a strong team focus, and we really enjoy rolling up our sleeves where we can and apply our specialist skills that we've learned across a huge number of projects to solve complex challenges. And the market sectors we operate in are across infrastructure, civils, urban bridge works, right through to facades and temporary works and construction engineering, which you're seeing more and more growth in as these projects get more and more complex each day. So the services that we provide as civil and structural engineers range right through from site due diligence and preliminary design, right through to construction support and value engineering and asset management services. So BG&E deliver projects in the residential space, a selection of some of our residential projects, commercial space we're very active in as well, public buildings, right through to museums, libraries, stadiums. We also work in the health sector as well, where we've delivered over 3,000 hospital beds in the last 15 years. Retail is a huge area for BG&E as well, and educational facilities and universities. Refurbishment and also industrial structures, including LNG containment tanks, are part of our portfolio as well. And construction engineering, we've dedicated teams in office centres working in construction engineering space, and they work closely with contractors to plan, sequence, and develop methods to deliver challenging designs safely. Our facades team is also very active in the Middle East and in Australia. And we're seeing more and more involvement, especially with some of the recent events with fire and also solar gain and acoustic services we provide in that space. Our materials technology is core to what we can do and provide in our projects today. It's become fundamental to our design delivery, especially when today's projects continually push the envelope, as we'll demonstrate in a couple of the projects presented today. So high-rise and super tall buildings. Today we'll focus on 3 recent BG&E projects in this area. So we generally consider buildings 100 meter plus as tall, 300 meters plus super tall, and 600 meters plus as mega tall. Now, each of these projects today I'm going to present on could be a presentation in itself, so I'll try I'll cover as much as I can in the time we have. The project selected could touch on some of Dennis's points about innovation in design, and definitely have very different challenges in each of these projects presented, and the solutions are also unique. So we'll try and run through these projects. The first one that I'd like to run through first is the Opus in Dubai. This is designed by Zaha Hadid, and it just opened in 2020. The form of the building, I think you'll agree, is quite unique. It's meant to represent an ice cube melting in the desert. The design was unveiled in 2007 by Zaha Hadid, and we ran into a good few budgetary challenges. Design challenges and the GFC threatened this project from ever being built. Nobody wanted to compromise on the flowing organic shapes to achieve the architectural vision. However, it had to stack up from a financial point of view for the project owner as well. So that's where I suppose we came in after the project was on hold for over 4 years. And with a contracting partner we did a huge number of work with in the Middle East, we developed a series of design innovations to assist in getting the project moving again. So the owners and the owners' agents wanted to create a premium property. However, the issue was that they weren't sure what the market would be like in 2 years' time when the project would be complete and ready for leasing. So we provided a post-tension banded slab solution to the floors, and this provided continued flexibility throughout construction and afterwards to accommodate a later fit out of change of use, mixed use as a hotel or residential or an office building. This gave the client a huge amount of confidence to move forward and address some of his concerns. So we also addressed the forward works packages and the piling packages, which were over budget initially. So we developed the design where we had 2 cores of the building working together to reduce the foundation and pile forces. So together with the weight savings in the PT floor solution, this enabled the project to get moving through the first gate, and we were off. So you can see the PT banded slab solution, a flat plate solution, and buttress column transfers was another innovative solution we introduced at level 4. Now this again gave flexibility to the building floor plate by removing transfer beams that would otherwise downstand and limit the use that space could be used for. So this gave the flexibility whether we needed to be as a plant level or a hotel lobby going forward. You can see originally the steel bridge or link, which is a 4-story link that links the 2 towers together, was quite large in footprint and required a huge number of complex lifting arrangements. What we were able to do was simplify the connection between the 2 towers. And you can see the footprint on the right-hand side and what we were able to achieve. Now, this is where I suppose the real innovation came into the building itself, where we used the 4-story bridge link as a rigid element, and that formed the portal with the 2 cores working together. This had the benefit of reducing the core forces, so in doing so reduces reinforcement, wall thicknesses, gave back more floor plate to each of the floor levels as well, and also provided a more efficient foundation system. And so how we model this, we used a series of ETAB staging models and be able to tie the 2 buildings together to be able to accommodate those forces in the slabs to take them back to the cores so they behave together. So effectively, we've got a large goalpost frame as opposed to how it was originally designed with 2 separate cores. These were the nodes, the typical node construction that we took out from each of the floor plates and joined the 2 towers together. You can see the program that we used was that we'd build out from each of the towers in a node by node arrangement. So the program was tight, and to allow working under this 4-story link, we also came up with a temporary deck to provide shelter and a working space below for the atrium levels to also continue. So this allowed multiple work fronts, which the contractor was able to utilize with helping clawback time in the program. So you can see how we approached it. So each of these nodes was unique, and it was built one by one, and the self weight of each node would slightly deflect as we built out. So we had to target a preset point at the center, and when the cantilever sections met in the middle, they'd join. And you can imagine, to our pleasure, this worked seamlessly and fell within 10 millimeters of each other and required minimal work to join the 2 sections together. We were very proud of how that worked out, and the contractor then was able to again move forward into his cladding operations sooner in the piece. This is a typical node being fabricated in the facility, and you can see the complexity of the joints here, which is a full capacity connection. and each of them was dropped in one by one to effectively form a cantilevered structure until it met in the middle and became a continuous structure. This is the crash deck that provided for separation of zones, so we could bring in a franner or smaller crane below, which was able to put into place the atrium steelwork while still having the steelwork above being worked on for the 4-story link. This is a shot of just how we are able to support the crash deck structure of the inclined column during construction. And then this is us working continually below that deck to bring in steel sections to build the aluminium, the atrium roof steelwork. So this is a shot of it during construction. You can see the cladding's already begun. So they're quite a tight schedule and they wanted to get this to market as soon as possible. These are some images of the node by node construction of the 4-story sections being built out from each tower side to their preset positions. And this is the atrium below, and where we used a composite deck solution for this, again, for being lightweight and to reduce volumes of concrete that needed to be pumped up into this area after. So it was worked through 24-hour schedule, construction schedule, 2 shifts. And this was the first section of the RHS to form the geometry for the atrium roof, which is that flowing profile to try and replicate the melting of the ice cube. This is further members being installed. These are all, architect want to achieve these within the same zone. So we work closely as well with the facade engineers to be able to position joints, because this spans over 75 meters, to locate movement joints that could get up afterwards and be maintained was quite a challenging process, to be able to locate them in positions that they wouldn't be difficult to access in the future and not create any maintenance issues. So this is the final form of the structural subframe before the cladding was wrapped. And then you can see it finished in 2020, and sadly Zaha Hadid passed away during the cladding of the building and never saw the finished article, but I think you can agree it's a fitting tribute to an amazing architect. The other one I just wanted to go straight into, I suppose, because I realize I'm running short on time already, is a project, Quay Quarter in Sydney. This is in Sydney Harbour. So this is a regeneration project, so very different in form from our previous project in Dubai. And this is a 250-meter tall building in the centre of Sydney. And this actually was going to be the most expensive commercial space to lease in all of Australia. It's highly sought after, which you'll probably see from the location imagery here. So it's located overlooking Sydney Harbour and the Royal Botanic Gardens. And it has a very unique stacked cake slice profile, this building. The regeneration is something we're going to see more of, I think, where we try to reuse and repurpose old buildings, not just for financial and program reasons, but also for embodied carbon counts and being conscious of, obviously, environmental crisis that you alluded to earlier on in the opening comments. So for this building, what we did is we took the existing core and floor plate. We're going to demolish, or we have demolished already, the northern third of the building, and then go down 3 levels of basement and build up and double the floor plate with a new composite construction, and also increase the overall height of the building. So this utilized the existing building structure core, and this solution also allowed the client to fall under the previous planning rules, and that allowed the building to actually gain additional floors because it wasn't subject to the new shadowing rules if you would have had a brownfield site. So here you can see the increased footprint of the core to allow for the new lifts to service the floor plate. And the floor plate in green, the new floor plate, is effectively doubling the overall current floor plate. So for this building, the architect wanted to create a vertical village, and this is a term that we're seeing used a lot now in high-rise, where you've got atriums linking floors to remote interaction. And it's quite an impressive view out over the Sydney Harbour as well. So there was multiple work fronts created to satisfy the contractor's very ambitious program. So we came in and assisted the contractor to work on the program that he promised he could deliver the client, how we could possibly do that. And the only way to do that was to open up multiple work fronts. So while we were demolishing the top of the building, we also needed to be building up from the basement with the new core as well at the same time. So the existing western elevation was demolished from the top down, and then the new core levels and the new basement slab was brought up independently from the existing building while the demolition continued. So you can see there was multiple work fronts to consider, and there was also differential movement. You can imagine how the core wanted to sway and heave and lead as the different stages were taking place. So first you're removing the load, demolishing the load from the front, so it wanted to lean back to the east, and then you were increasing the load as you built up the new core and the new floors, which were bringing it back west again. So it was quite a complex analysis that needed to be carried out to understand how this building behaved. So we chose to use steel, prefabricated steel columns. Now these were concrete filled for fire requirements, but the shortening of these new steel columns was carefully calculated so that each column was fabricated to a higher level when it was tying in with each floor. So in the final position, underneath the shortening of the dead weight of the building, that would allow the floors run flush. Now, some of these columns shortened between 30 and 40 mil over the 200 meters, as you can imagine. So again, this was closely monitored as we went through the construction to make sure that each floor level aligned exactly. Otherwise, there would have to be modifications in the steelwork process to make amendments should any of our calculations be wrong, which they ended up being correct, which is fantastic. Here's some of the complexities in the modeling. So there was a huge number of stages to consider. So we did this as 4D stage analysis, again, to understand the forces in the core originally, then when you demolished it, then the forces that came back into the core when you added the new floor plate into it. So there was a huge number of varying conditions that this building, over 30, was analyzed under. And that involved a very strenuous and tedious surveying routine for the building. So we did, there's numerous tilt centers and strain gauges positioned throughout the building, and the surveying and monitoring during the construction was a full-time exercise, continually checking the strain and the movements in the building, and that they matched the theoretical models that we developed. You can see here just an example of some of the movements that take place. This is a plumb bob dropped straight down from the top of the existing core, and it would move between different construction stages as much as 20-25 mil. So as well as obviously the complexities around the movements, there's also a lot of work done for temporary engineering with the contractor. So we also provided the full engineering services for this because of the complexity involved in the temporary condition for these state of this building as it was erected. So this is some of the temporary staging that was conducted. To enable the construction of the inclined and hanging columns, we had a temporary cantilevered platform support that was withdrawn back and eventually used as part of the permanent structure as well. This is the void that was formed in the existing footprints to the west of the core. So you can see the size of the openings that were cut in the existing floor plate. And this also had, you can see the top of that image, provided a crash deck and protected zone, so they could demolish above while building up safely below in this area. You can also see from the images here that we were coming up with inclined columns as well, which also put in horizontal forces into the existing core as we raised and poured each floor until we had a chance to strap it back at its when it returned to the new core position. This is the construction of the new core wall starting at lower level within the void that we created within the existing floor plate. You can see here that the new cores were built up through the openings formed in the existing floor. And then we used the remaining floor slab, which is another clever use of existing structure, to provide a horizontal member spanning to control, basically to seal the environment, and that supported the existing columns until the time was that they were demolished afterwards. Now the core that we were bringing up through this zone had to be considered carefully, because when we were casting the new lift cores, they had to stop at every second floor. And then we left the 400 mil gap between the cores and continued up. Now, the reason why we stopped and started was if we poured a whole new core up against the existing core, the hydration forces alone would create and pull the existing core much more than it had capacity to withstand. So we came back and did a delay strip, and we came back after the concrete had chance to hydrate. And we came back a few weeks later and poured the 400 mil strip around, and that actually alleviated the new forces going in to the existing core. So again, a very innovative technique, and we work closely with the materials and material scientists within our team to be able to work on the exact strains that would be induced in the existing core through that movement. The hanging columns was another feature, as you can imagine, with the stacked triangle profiles, that you couldn't get continuity on some of the columns on the corners. So these had to be hung and take those forces taken back onto the main line of support, which you can see here's some of the key transfers at different stages until it's finally the floors have caught up with the vertical load path for the hanger, and then the inclined column will take it in the permanent case. So here's some images of Quay Quarter overlooking the harbour, and there's a lightweight construction used with the metal deck, the composite metal deck, and steel columns were selected for the new floor plate. And this is to reduce the loads and hence reduce the shortening, and made it easier to control the shortening underneath the new forces. Ribbon stairs were also used, which our structural engineers are very proud of. These ribbon stairs are used to link the vertical atrium spaces in a corkscrew design. As you can see, there's no columns. And again, they were installed without an issue. The building's wrapped in facade cassettes, and these incorporate the shading to reduce the solar gains on the buildings in those naturally lit atrium spaces. And this is the building close to having the cladding complete. Some of the detailing, finishing with the Sydney sandstone, which is a very common material. So this is the vision that we achieved at the end of the stacked volumes, which provide these vertically linked spaces. So that was Quay Quarter in Sydney. I'm not sure, Habibi, am I okay for time to show one more? Or
Yes, yes.
are you sure? Okay,
Sure.
I just wanted to check. I know all your time is precious. Okay, so some other projects that BJNE obviously very proud of. You see here is one Zabeel in the top left, which is the world's largest cantilever structure. The Binary Building in the Middle East as well. We've got Perth Museum, and we've got the Duxton and Copen Gate, which is another building that we're in the process of designing at the moment, which has a cantilevered stayed bridge link over an active harbour, which is another impressive one. But what I might do is, if I have the time, then is quickly show you some slides on One Zabeel, which is a very recent project we're working on. So this is a very high-profile project. This is labelled as the gateway to Dubai's financial centre, and as I stated, has the world's longest cantilevered building link. Now, this link spans between two towers, Tower A, the taller tower, and Tower B. So Tower A is 310 meters and Tower B is about 270 meters. The link itself is 4 stories, and it's 80 meters by 80 meters box section. It's got an infinity pool in it, function rooms for the hotel, and quite some views, as you can imagine. And the cantilever itself is over 60 meters past the face of Tower A. So you can imagine the construction engineering challenges involved in this. So what we did was we used our bridge techniques and skill sets and applied them to this complex problem. So in between the two towers is 6-lane highway that had to remain open. So what we propose to do, incrementally launched structures are one of our specialist skills that we have in the bridge space, but we hadn't used it for this purpose for a building, but it lended itself to the same challenges and solutions that we'd see in bridges. So what we did is we were able to fabricate the bridge on the far abutment and then jack it horizontally across the elevated roadway to here, the viaduct, and then lift it vertically, jack it up into place in its final position, 100 meters above the ground. So to do this, we'd come in and do a number of strengthening, because you could imagine the horizontal forces that are generated when trying to jack a structure of this size into it. There just wasn't designed for it. So we had to come in and put in these temporary struts to strengthen the podium structure to enable the jacking take place. This is the sliding feet that you see. We're moving horizontally along, and then we'll carry over the 6-lane highway. These are the jacks. So the jacks pushed to incrementally launch the bridge, initial bridge section. And as each section was built, we added to the overall footprint of the link, the bridge link. Again, it was pushed forward, then we added another section behind, and we continually did that until we reached the far side. So here's a photograph of it, the nose of the link crossing over the highway. This is just the soffit as it's just about to land on the far side. The yellow part of this bridge, by the way, was removed afterwards, and this is just the nose for controlling the initial push, so it can rest on the bearing and the guides. And there was some very complex behaviors that started to need to be considered, because the two towers were actually under construction and not even at full height while we were doing this. Again, working closely with the contractor, we couldn't wait until the two towers were built to come back and then lift up the bridge link between the two, as you probably traditionally would do. This had to be done during the construction of the towers, but the towers didn't have their full weight on them or have the full impacts of shrinkage through hydration of the concrete. So again, it was a very complex modeling technique that we developed to see how the building behaved during each of these stages. So here's what the building wanted to do. So you can see, if we were to just jack it up afterwards, we would have pulled the building as much as 150 mil in one direction, and it would have skewed. So to cater for this, we had to build the building with presets. So effectively build it with purposely deform the columns and the floor plates as we went up. So in the final situation, the building would arrive plumb and wouldn't be any issues. So this involved a number of analysis and modeling that we did in ETABS through 4D and stage modeling again, and continually changing the set out points for the contractors and their subcontracting teams to set out the column positions as we rose up each floor level. So you can see on the left-hand side for Tower A, without the preset, the blue line, just how much it would have moved. And then with the presets is what we were trying to achieve as it was constructed. So that's what we were chasing in the construction. And now to do this, what we had to do was we had to, instead of building a column vertically at key levels, which you can see indicated here at level 20, we have a crank in the steel columns, say over 2 floors. We go up vertically again to level 30, we crank the column again. So they're the type of presets that were built into the building to enable us then, as we jacked, to be able to pull the building plumb as it's constructed. So some of these splice joints in these steel columns, some of them took up to 3 weeks to do with continual welding. And generally we performed them very early in the morning, so there was less locked in stresses in the welding in the joints. Again, one less thing to, I suppose, reduce the impacts of when we're doing our complex calculations. So this is what we were able to achieve in the end, through a number of survey points positioned throughout the building and through the bridge link. And we had a huge number of surveyors continually monitoring each of these points and making and advising any corrections that needs to be made when it's strayed from the theoretical modeling. So Eber Sendai were the structural steel specialists that worked with us. And this is just a typical mapping and monitoring exercise done during one of the lifts. And this is where the strands were actually jacked vertically to take the bridge link into its final position. So here's the jack positions as it's lifting up the section. And then what we also did was, it was too heavy to jack in its entirety. So what we did once we got it locked into the final position, we added, you can see on the photograph on the right, these secondary jacks. And how these secondary jacks behaved was, when they were in their final position, they lifted up the nose of the cantilever, and this gave it its final length and geometry. So that's it in its final position. The cantilever just before the secondary jacks then were all removed and taken down. And that's within one of the 4 stories within the volume. One of our guys standing in there. So this is the Tower A and B and the structure in October before the nose, you can see at the podium level, hasn't even been lifted up in place. And then just last month, you can see the full cantilever form being taken and the cladding almost complete. So thank you for allowing me run through some of those projects. I really, really hope you found them interesting. I'm happy to take any questions, but I'm aware that Yi Chong as well has to present too. So yeah, thank you very much.
Okay, thank you very much. That was really a nice, interesting presentation. I believe our engineers who attend this event would like to ask questions later on in the Q&A session.
Sure.
Yeah, and Neil, that you have pointed the complexity of your projects, talking about 3 study cases, 2 projects in Dubai, and I think 1 project in Sydney. Yeah, it's more on the structural engineering point of view. Okay, I don't want to spend more time talking here as moderator, so let's give the opportunity to to architect Itiong to deliver his speech and presentation. Yeah, please, Itiong.
Hi,
Time is yours.
thanks, Pak Habibi. Yep, it's a new fantastic, presentation. Yeah, I'm just going to share screen. Let me know when you see my screen.
It's still on the way from Singapore to Jakarta. Not shown yet. Yeah, we all can see it now. Itiong, we kind of miss you. Maybe you are muted.
Yes, I was. Hi, Habibi. Thanks. Hi, good afternoon, everyone. I'm Itiong, Gensler Singapore Studio Director. Thank you so much, for the invitation, to speak at this international webinar on high-rise building development, design and construction innovation. I'd like to thank the Institute of Engineers, Indonesia, and the organizers, for this invitation. First, I'd like to give everyone a quick introduction of Gensler before going into the topic of my talk today. And Gensler is a firm that originated from the US. We are close to about 5,000 over staff worldwide, located in 49 offices, and which is then split up into 11 regions for ease of management. And at one point of time, we are servicing 4,300 of our clients worldwide. And the things that in Asia Pacific, and Middle East, Greater China, we're looking at 11 offices of 700 over team members. So Gensler is the largest, architecture design firm in the world. We've been in existence since 1965, and the things that we've completed, 10,000 over projects annually, with 500 over design awards, with those projects. As mentioned earlier, it's there are 11 offices within Asia Pacific, Middle East, and this slide literally charts and shows where we're located. The Singapore office is in fact the Asia Pacific Middle East hub, whereby from Singapore office, we manage the other offices: Tokyo, Sydney, Bangkok, Bangalore, Mumbai, Abu Dhabi, Dubai, and of course within China. It is a separate region. It is called the Greater China region of Shanghai, Hong Kong, and Beijing. So within Gensler itself, we do have got our integrated industry experience, whereby we have identified 28 practice areas. And this is in fact across 4 different sectors of community, health, work, and lifestyle. And as you can see here is let's just say, for instance, community, there's aviation, critical facilities, cities, urban design, education. Workplace has got the various other sectors, so does lifestyle and healthcare. And what we're seeing nowadays is a lot of projects that we are engaged on are mixed use in nature. And the things that with such projects, we do bring on board the best of talents within Gensler, and it doesn't matter where they are from, but as long as they've got the appropriate experiences, they will be on board the project. And what are we proud of? We're proud of research and innovation that we bring to our clients through the insights and our experience and knowledge working on projects, on our global projects, like projects in the US, Europe, Middle East, Asia Pacific. These projects that we work on then become benchmark for projects that we work with our client on. And the things that working on those projects, we have those information and knowledge, and we are our clients' best partners. So through that, it's we do in fact put forward about 17 to 80% of our profit into research. And what we're also proud of is also community impact. We contribute about 130 over 1,000 hours into community sort of like engagements, to charitable organization, not-for-profit organizations, globally. And the things that, what is very close to our heart is sustainability commitment. We've signed the Paris Pledge, for action because we want to be part of the solution. Yeah, as we're committed, to leading the design and construction process in a lot of our projects. Diversity, equity, and inclusion. And the things that we're seeing, sort of like diversity is foundational, like to our one firm culture, and we believe that diverse teams with different backgrounds, different sort of experiences will bring design innovation. And the lady on the top left-hand corner that you see is Diane Hoskin, addressing the United Nations in 2019. The things that is when she was invited, to speak at the UN, United Nations, and the things that's when we had, our Paris Pledge on the commitment by the firm to ensure that all if not most of our projects are sustainable, has got sort of like green building strategies in them. And the things that we've have got about 1,000 over sort of like LEED accredited professionals with over 1,500 LEED certified soil projects. So just touching on some of the iconic projects that some of you may be familiar with, the Shanghai Tower. The tower on the extreme right, it is by Gensler. That's the tallest tower in China at 632 meters tall. And this project, in fact, involved 13 officers of Genslers and hundreds of our staff, that was involved in this project that we're very, very proud to have delivered in Shanghai. The next project is Xiamen Shimao Streets Tower. The tallest one, the tallest sort of twin tower projects, in China. This it stands at 300 meters tall, about 350,000 square meters in total GFA. The next project is the Ritz-Carlton project and Fairmont mixed-use development project, in LA. For those who are basketball players will know that, LA Lakers play at, the stadium to the left. They will see in this photograph. And the things that a lot of people going for the games, will be staying in this development. And closer to Southeast Asia, or in Southeast Asia, closer to Singapore and Indonesia, is this Waldorf Astoria Bangkok project at 60 stories. This project is one of our pride and joy, one of the tallest soil towers in Bangkok. And this is, in fact, a project that's currently under construction in India. And the things, this is a project that is a high-end luxury residential project, which also includes our clients' private residence. And this project, we have included a lot of like biophilic design ideas. As you can see, so a lot of greenery at the podium and at the top of the tower. And the things that the client had the vision that he wanted his house to be a tree house. And the things that this is where we brought visions to reality. Yes, and now, like moving on to the topic of my talk today, it's the next great urban design challenge. Something that Dennis has mentioned, the importance of sustainability. It's creating sustainable communities in vertical cities. Yeah, and I would touch on design resilience trends and strategies applicable to our built environment. Yeah, it will also include a showcase of a series of Gensler global projects that is designed with sustainability and resilience in mind. So 7.7 billion people, 7.7 billion people worldwide, are vulnerable to effects of changing climate, like such as rising sea level, floods, drought, natural disasters, many of which that we've seen over the last 1 to 2 years. Like be it in the US, in Europe, sort of like forest fires, floods, typhoons. And this disasters appears to be on an increasing trend. And the things as professionals in the built environment sector, every day, through our work in creating places where people live, work, and play, we impact lives of millions of people. All of us, contributing to built environment sector have the important role in making a positive difference in the world through our work. Like by being proactive in engaging our projects, bearing in mind that we can impact climate crisis or climate change, through our buildings that we develop, design, engineer, and construct. We have the ability to reduce the carbon footprint of our buildings. And of course, of recent, it's like just on Monday, it was the kickoff of the 26th Conference of Parties, a global climate summit that took place in Glasgow. And we saw more than 100 world leaders and thousands of attendees coming together to discuss the future of global climate crisis and to negotiate ways to strategize and to build a sustainable future. And in 2020, Gensler, we designed over 1 billion square feet of space. And that's why, even more so, we are committed to designing with an unwavering focus, on human experience, with in mind sustainability strategies to shape the future of our cities. Addressing climate crisis is more important than ever, and together, we can create an era of global wellness. And the things that with, the COVID that took place over the last 1.5 to 2 years, we are even more aware not only of climate crisis, but the things that its impact on our health and wellness. The Gensler Cities Climate Challenge, which we call GC3, is our commitment to achieving carbon neutrality in all our work within the next decade. It is a rallying cry for the industry, for our partners, our team members, within Gensler, our clients, to have this greater awareness of the climate crisis and really to make a change and an impact on all the developments they're involved in. This is just a chart that shows the impact that buildings have on the consumption of energy. And this is just a chart from US energy consumption, the US Energy Information Administration, and it shows that in fact 14% of embodied energy is it comes from the building sector, and 35% is from operating energy of the building sector, and altogether 49% of energy consumption is from the built environment. So the things that in terms of the total net carbon impact, it really is the sum of embodied carbon with operating carbon, minus off the carbon offsets. But the things that what we need to do is, as much as possible, try to reduce the amount of embodied carbon and operating carbon as such that the carbon offsets can literally, truly offset the making and the using of buildings. So this is just a list of some strategies that really highlights what we need to think of when we are embarking on our projects, when we are designing and developing our buildings. Right sizing, having strategies that use the fewest materials possible, without of course sacrificing the original design intent and the functional use of the building. Significant reduction through low and zero impact materials. We look at gradual increase in reusing of existing buildings and repositioning of buildings rather than building new builds. In terms of operating carbon, using the buildings, series of strategies too, strategies that use the least space possible without sacrificing function. Significant reduction in operating energy per square foot, gradual increase in on-site renewable energy production, and electrification, to increase flexibility for renewable procurement. So these are a series of strategies, for climate resilience, which in fact, touch on design strategies that considers reuse, saving from the savings from reuse, can reach as high as 50%. If existing building has been repositioned rather than being demolished and built new. In terms of shape and size, of our buildings, through passive design. In terms of materials, considering the source of materials, where are they from, and can we procure local materials rather than having them shipped from overseas? And things are what about recycling of materials? We looked at water. In fact, how to reduce the amount of transportation of water and how we can, in fact, harvest the rainwater for use. Energy, it's like, how we can use renewable solar energy sources and minimizing energy use with efficient equipment. And the things that those are a series of design strategies that we as architects work very, very closely with engineers. And the things that within Gensler, we have a concept of resilience that we term beyond sustainability. It is a term that we use to recognize that our design must constantly evolve. It must adapt to needs. It must be future-proof by being prepared for the changing world. Climate resilience, which is one of the sort of like sort of like areas that we look at, where as the climate continues to shift, we must invent new ways for cities and its built elements to enrich the human experience within a changing environment. And the things that 23% of people live in cities globally, and of which more than 80% of global GDP, is generated from cities. And with that, of course, it's no surprise that 70% of all carbon emissions come from cities. And as highlighted earlier by Pak Dennis, is that there is a challenge faced, by Indonesia, whereby 52% of people are living like urban areas, and the thing is that by 2025, 65%, and then by 2035, 70%. So there will be an increase in the number of people living in cities. And the things that our goal, is to eliminate all greenhouse gases, or to reduce them as much as possible, associated with the built environment. And this can be carried out, through passive design strategies of building, massing, facades, and its orientation. And this is one project, that we successfully achieved in achieving carbon net zero goals. This is development which is termed the Eve Park project in Ontario, Canada. It's under development, and this is a project whereby we work very, very closely with a client on this townhouse residential concept, where it literally is net zero carbon. And the things that we're looking at a series of passive design strategies to conserve energy. And this is through simply building orientation coupled with solar shading devices that reduces solar heat gain and solar heat glare. And as you can see, the diagrams on the left, that shows us working through modeling over the course of a year through computational analysis of performance of the building, in reducing the amount of solar heat gain and heat glare. And in this project, there is also consideration and emphasis of a holistic approach of energy conservation. There's a series of sustainability strategies, which includes rainwater harvesting, on the roof and on the ground plane. And we've considered a series of photovoltaic cells, on the roof. We have green roof to reduce the solar heat gain. We're looking at solar fenestrations, solar shading devices on the facades, natural ventilation. As you can see, we're looking at how natural air could be drawn into the spaces. Looking at landscaping, the use of material, and to try to procure local material as much as possible that is close to our site of construction. And the things that within this project, there's also a series of innovations in terms of electric vehicle use and parking and storage. And the next project that I'd like to share is a project in Vietnam. This project was recently complete last year. We are very proud that this is one of our flagship projects in Vietnam. where we went through the same sustainable strategies in designing the project. And this is a LEED Gold project and a sort of like a Asia Pacific Property Awards like winning project. Yeah, this office building is approximately 23,000 square meters in total GFA. It primarily comprises of high spec corporate workplace for Viettel headquarters, a telco company in Vietnam. And with this project, as you can see, there's a green roof, solar voltaic cells, which also doubles as skylight into the office spaces, a series of outdoor terraces, for the enjoyment of the staff. And the things that, this is just a slide that shows, a series of sustainable sort of strategies and features within the building. Yeah, and the next sort of like a strategy or topic I'd like to touch on will be ecological resilience. Through ecological resilience, we are able to retool cities and its built environment to create more biophilic habitats that contribute to the ecosystem. We need to understand that 51% of habitable land is covered by developments. That we have to consider land not just for developments as in buildings, but what about land for greenery, open parks, plaza, nature reserves, for the enjoyment, of the inhabitants of the cities. 95% of population increase, over the next decade, will be in cities, and we should be creating and adapting the built environment through ecological and biophilic design to support the ability of natural or native flora and fauna to thrive. And this greenery and landscaping, in fact, helps mitigate and reduce urban heat island effect, which in turn makes a city sort of like more livable, and it helps to sort of like allow sort of lesser consumption in energy for cooling with more greenery and landscaping. 78% of all precipitation sort of hitting the green roof or green terraces is retained and prevented from flowing into the sewer system. And this catchment of water can be reused to hydrate the landscape, and if not, incidents of like sewage sort of like requirements within sort of like developments. This is Capital Land Rochester Commons project in Singapore. Very, very proud to have been part of the team in delivering this project. This project is in fact under construction now and scheduled to complete sometime latter part of next year. It comprises of about 37,000 square meters total GFA, and houses an office, a boutique hotel in the mid section, its senior executive learning center to the likes of Insight, and the things that there's a series of F&B offering on the ground plane. This development itself, besides the tower, is in fact connected to 12 black and white colonial bungalows linked by this green spine. So this green spine has got a green roof that literally reduces the amount of heat gain and helps in the cooling of the space underneath this green spine, which besides acting as a covered walkway, has a series of activity pods like within this green spine. And this in fact links to every single one of these 12 colonial bungalows, which will in fact serve as F&B or as learning facilities for this senior executive learning center. Yeah, and this, as you can see in this image here, it shows the biophilic strategies of landscapes of like facades that literally cascades, from the top of the building to its podium and onto the green roof. Yeah, the green, and this is in fact, a close-up, of, the green roof and how it cascades down, sort of like, and how it connects to the various black and white bungalows. And this part, this is in fact an infinity pool that's connected to the boutique hotel. This is in fact a close-up of the boutique hotel, with its outdoor terraces and landscaping. And this is another view of how this sort of like green spine connects to this colonial bungalow. And then with a series of activity spaces that is sheltered from the weather just underneath this green spine. Yeah, the next project I'd like to share is the Morphable office project in Baltimore. Yeah, this is a conceptual project in collaboration with Arup, where we were rethinking the basic model of an office building. Yeah, with COVID, hybrid working is here to stay. And the things that many times when we engage our clients, there's always this question of how do they, in fact, attract their staff to come back to the office. And this could be answered, through a series of the attractions and how do you bring talents back into the office. And through this exercise, we have showcased a series of health and wellness design strategies that's been employed with sustainability in mind. And this includes sort of like easy accessibility to outdoor spaces, access to nature, to natural daylight, to natural air, and the things that how this site is fully accessible, to the public by creating sort of like this open plaza on the ground plane, whereby 85% of this site area is fully accessible to the public. And this in turn, in fact, increases footfall and optimizes the potential for retail and F&B offering. And next, I'll touch on functional resilience, whereby the longevity in the building environment depends largely on the ability to evolve as needs change. And the things that for this, it's like, we're talking about repositioning of existing buildings, whereby, we can literally save like 50% of sort of like carbon footprint, like through the reuse of a building rather than demolishing an existing one and building a new building. And our goal is to create sort of adaptable buildings and to allow the cities to have longer sort of like allowing these buildings to have longer useful lives. And this One Post Office Square project in the US, whereby this building was built in the 1980s, 1981. And the things that, as you can see, sort of like how we worked very, very closely with the client to reposition it, in terms of having a more efficient and effective facades, on the exterior envelope of the building, and then how we totally maximize, the activation spaces in terms of having sort of like F&B offering, not only on the ground plane, but, at the roof terrace. And the things that how we increase the floor area and, the plot ratio of the building with the addition of an attachment to this existing building. This is just one example in the US. And the things that this in fact does have this 50% sort of like carbon reduction. And this is just a section of how we adapted the ground plane of the building to allow for more sort of like community-like spaces, like for the users of the offices. This is another project in Portland House in the UK, by Tottenham Court Road. For those who's familiar with London, this building here that you see was completed in 1963. And it's in fact, one of the tallest towers, in central London for the longest time. Yeah. And in this project, we looked at adaptive reuse of the existing building, and then how we're increasing sort of like areas to the rooftop, and how we're increasing sort of areas with an extension to this building with a series of F&B offerings, as you can see in the yellow block over here. This is a section, or this is a sort of a perspective of the interior of the building. On the left, you see the existing building where its facades has been totally stripped out, where its structure, is proudly sort of showcased. And on the right, you see the new extension to the building. And right in the middle, where there's an amazing light well that brings in natural daylight, it does bring brings so much sort of like natural sunlight into the depths of the building, even on the ground floor. And for this project itself, 54, we work very, very closely with the engineers and worked out that there's 54% reduction in carbon emissions on this adaptive reuse of this building versus building a new one. And the things that this image literally just shows, like, a function, sort of like a multi-purpose sort of like functional space on the rooftop, and a series of F&B offering on the sort of like the Sky Terrace. And the next topic I'll touch on will be on design intelligence, whereby data-driven design and simulation will reveal to us the opportunities that frame the impacts and identify sort of creative options for spatial quality and human experience and construction costs. And whereby 35% of every dollar spent on construction is wasted through inefficiencies in productivity, be it in communication, workflow, accuracies of information. And the things that if you're looking at 35% of every dollar spent on construction, this is roughly 8 times the total fees of engineers and architects and consultants on any given project. Yeah, and our goal is to develop sort of like new data-rich modeling and simulation capabilities to discover unprecedented design that will assist in sort of like policy and planning opportunities that we uncover on each and every one of our projects. And the things that through the use of BIM, that was also highlighted, in the earlier opening speech by Dennis, we strongly believe that BIM will allow for more accurate, coordinated sort of information to be disseminated for any of these building projects, whereby there could be potentially 45% reduction in change order. And the things that within Gensler itself, all and every one of our offices are BIM capable. We are using sort of Revit as a software and a program, not just for design, but we see it as a future, whereby it does then become a digital twin to the buildings, and the things that the developers and the owners could use this digital twin to better assess the performance of the buildings. And this is a project, Adobe North Tower project in San Jose, by Gensler. And on this project, what we did was that we literally unraveled the elevations, and from there we mapped out the facades, and through sort of like the solar path through the day and over the course of a year, we mapped out sort of like what is the most efficient sort of like facade module and panels that should be applied onto the building elevation. And with that, we actually worked out, let's just say, what is the construction cost, or what is the unit cost for each of these panels, and we worked out sort of like the optimized sort of like performance of the elevation versus the construction cost to derive at the most optimal construction costs versus performance of building. As you can see here is like how we derived that a unit value for the facades, but with optimal building envelope performance. And that was a project that's in fact under construction. And this is the project that was in fact realized in Singapore. It's the Capital Land 79 Robinson project. And this literally has got the same sort of like concept and idea behind how we harnessed and worked out the reduction of solar heat gain on facades through the slight tilting of the facade panels. In fact, all these panels are of the same sort of like makeup, but the things are just a slight incline of this facade panels helps. In fact, what we worked out is that with this slight incline, it actually helps in reducing approximately 11 to 12% of solar heat gain into the interiors of the office space. Yeah, and this is another project, where the Gensler team accomplished Yeah, this is in fact the Shore Contract project in Atlanta, yeah, where we worked with our in-house design technology team. Like through the use of computational analysis software, we're able to derive 346 design options, under 4 hours, which assessed the most efficient facade at the least cost. And this process allowed us to reduce material usage by approximately 21%. And the things that through this process, we're also able to have 62% less solar heat gain, solar glare, like into the interiors of the building. This next project is in fact a project in Manila. And the things that this project went through a design process of having 1,200 building massing options analyzed in 10 minutes. And the things that this is through a software that we developed in-house to work out the optimal building shape in response to the design requirements, to its surroundings and environmental conditions. And this is just a series of analysis diagrams that we carried out on the final proposal to ascertain the performance of the building. This next project is in fact Shimao Fuzhou project, 108 stories tall project in Fuzhou. And the things that this project in fact has applied the same sort of design process as our Shanghai Tower project, whereby the Shanghai Tower project, through sort of the understanding of the wind load and wind flow, the entire shape and form of the building was designed sort of to counter or to reduce the amount of lateral wind loads. And this is the project where we applied the same sort of design thinking. And this is just a series of diagrams that showed sort of wind analysis, desktop wind analysis studies. And the things that we've got internal atriums that allows natural daylight in with landscape features. And the things that for this project itself, the 45 degrees front. There's just a rooftop, observation deck of the project. Yeah, building intelligence, high performance buildings and interactive environments anticipate the needs of people. And the things that if the building is intelligent enough and can have such sort of seamless interactions and incorporate intelligent spaces and services, it will then improve, help improve the value of the real estate asset. 40% of buildings of energy use is to compensate for heat gain and heat loss through the building envelope. Yeah, and the things that we have to deliver more intelligent buildings powered by technology and artificial intelligence. And with this, it will help advance the autonomy of our environments to empower people. And the things that over 80% of new office construction involve at least one facet of IoT or related smart building technologies. And this could in fact have approximately 18% savings on sort of utility bills for companies with smart building technology. This is a project in Zhuhai, China, Huace Plaza, and this has got this living, breathing facade system that we work very, very closely with our engineers on. It's based on IoT sensors that measures the quality of air, light, humidity levels of the interior space, and through controlling of the HVAC lighting and facade systems, it modulates, and allows the optimal sort of comfort level to be achieved for the interior spaces. Yeah, and in fact, for this is in fact realized in our project, which is the PNC Plaza Tower in Pittsburgh, where it's designed with sustainability and building efficiency in mind. This is in fact a LEED Platinum project that's equipped with a full suite of sustainability features from its double skin facade to the effective material use and selection of its MEP equipment. So over here, it's just a diagram that shows how this facades is automated and allows for fresh air to be drawn through the facade, through the office space, through the core, up through this chimney, and out and exhausted through a top sort of like vertical exhaust fin. And this project has been proved to be a success in reducing a substantial amount of sort of like energy consumption just for the exchange of airflow. Next project I'll touch on would be the Johnson Controls Asia Pacific headquarters project in Shanghai, where we actually did achieve 45% savings in overall energy consumption and 42% savings in water usage through rainwater harvesting. And the things that this project is equipped with a full suite of features besides passive green features of green roof, solar panels. It's also equipped with Johnson Controls proprietary distribution energy storage units and optimized central plant that help reduce heating and cooling energy requirements. And then with that, it's like that's the last project I'm sharing. And within Gensler itself, we are a stickler for data, and we track the building performances of our projects. And this is in fact a diagram that shows a 2019 portfolio of our projects, whereby there is a savings of over 16 million tons of carbon dioxide emission, whereby in total we designed for about 1.5 billion square feet of space, of which 1.2 billion is buildings, attributed buildings, another 350,000 million square feet attributed to the interior design project that we embark on. And this is just a breakdown of showing the performances of our building projects, as in how in our Gensler portfolio it performs much better than a typical EUI baseline, and how the top 20 most sustainable projects perform way better than the the baseline. And for the interiors project, we also have got the same and similar benchmarking on tracking the performances of our projects. Yeah, and with that, I'll end my presentation. That we all have got a part to play, in tackling climate crisis, through all our projects that we engage in and embark on. And the things that this can only be done with concerted effort by developers, by architects, by engineers, by all the consultants coming together, as a a cohesive team delivering a holistic design approach. Yeah, thank you.
Thank you. Thank you. It's a nice, exciting presentation, Architect Ee Tiong. It gives us insights, knowledge, more on the design development for buildings, which need to consider the strategies for climate resilience. You're talking about reuse, size and shape, materials, water and energy for the building design. Yeah, and I recorded also there are so many projects, case studies started from the Eve Park in Ontario, Canada, and then Viettel in Vietnam, until the Finance Center in Philippines that you designed that building as well. And one more that I can recall that you mentioned that 70% of all carbon emission coming from the cities. I certainly agree with you, Ee Tiong. And the greatest achievement of Gensler, what I wrote on my paper that you're talking about 16 million metric ton CO2 emission, yeah, in 2019. So you save in terms of carbon footprint reduction that you are contributing more on that. Okay, before we go to question and answer session, I would like to give 5 minutes time to Engineer Andi Sanjaya Chong to give or to provide comments as well as questions to both speakers. Thank you. Yeah, please, Pak Andi.
Okay, thanks, Pak Habibie. Nice presentation for both. Yep, I'm going to give my comments for both presentations, and we'll have questions for both speakers. So for the first presentation, right, mostly it's about structural design. All projects have challenges in geometry and structural system that need a complex planning, design, and execution. It needs a solid collaboration between all the disciplines, especially the architects and the structural engineer. Also, during the construction stage, need to have a good construction and supervision team. Since these projects are considered a very complex project, in my opinion, a small mistake may lead to a big disaster. So my question to Neil, what are the challenges encountered in the foundation system for the key quarter project, especially the differential settlement between the existing building and the new section of the building? So for the second presentation is more for sustainability design. Nowadays, sustainability is an important factor for all aspects, not only in energy-related sectors, but also in building development. In Singapore, the Building Authority enforces the development project to meet the sustainability criteria, which is the building must pass certain green mark scores. My opinion, I think to design a sustainable building is not as straightforward compared than like food product resources, sustainable food product, or the renewable energy is just one component. But for the building, we have a lot of aspects and a lot of small components that need expertise to design. But of course, also this also will increase the project cost for the entire project. But I think we can treat it as an initial investment. You pay more at the early stage, but you can gain reducement in the operating costs. So for my question to Ee Tiong, what in your experience and opinion is the best practice for sustainability design on your projects? Yep, that's all, Pak Habibie, from my side.
Thank you, Engineer Andi. I think both speakers can directly answer the questions, and later on we can go to the open floor where all the participants can also raise questions. Please, Pak Neil, Pak Ee Tiong.
Sure. Thanks, Andy, for questions. I'll pick up on your question, I suppose, to do first of all with the foundation approach for Quay Quarter. So Quay Quarter is founded in Sydney sandstone, which is actually a fantastic base for constructing buildings. It's got a very, very high bearing capacity and obviously a very low settlement. So when it came to differential settlements, it wasn't largely driven by the substrata. The complexity was using the existing core and building, and then building the new steel composite structure beside it. So the complexities, though, you're right, a small error in the calculation could result in quite a catastrophic failure if you don't understand what you're doing. Like I alluded to with pouring a new concrete core up against an existing one, and not understanding how the behavior of concrete as it hydrates and the strains and the pull and heave that would put on the existing structure. So to do that, though, there was a very, very arduous task undertaken, first of all, of modeling theoretically, but then on site we also took a huge number, over 10,000 samples from around the site, from existing concrete columns, cores, and sections of the building as well. And that was all lab tested to confirm the properties of the materials too. And then off the back of that, we applied strain gauges in key areas of the building and monitored them regularly to make sure that it was behaving as per our theoretical calculations. So yes, absolutely, it can have a catastrophic effect if you don't understand. But I find we're going to see more and more of this going forward, and it's so important that we get a keen understanding and we develop and pass on this expertise onto other projects as well, so we can learn rather than reinventing the wheel for each one, because the limits are being pushed. You can see some of those fantastic projects that Yi Kyung shared there as well today, that they're just, I mean, reaching for the stars, and the clients are asking for more and more, and we'd love to see assist them and achieve that. So yeah, definitely ongoing monitoring, I'd say, is the answer to that, and understanding your scientific properties, your materials, getting a good engineer, Andy.
And we know where to find a good engineer.
Agree with you, Neil.
Yeah, and the things are just following up on sort of like Neil's response to Andy's question. You know, and Andy did ask the question, so how what's the best sort of like approach to any project, and in putting forward sustainability strategies. I feel that it's very important for us to communicate, to have good and clear communication with all the various stakeholders, with the client, and understanding their needs on the project, understanding the background of, you know, the project itself. You know, how can we as professionals support and assist them? Of course, you know, with developers, that is very who's been around the sector, who's been carrying out developments for a long time. You know, of course, you know, they may be familiar with sustainability approach. But however, for new developers, you know, it could be that, you know, whereby such knowledge needs to be imparted. However, having said so, it's like, you know, on all the projects, I think it's important for, you know, the architects, the engineers, to really put forward sort of like passive design solutions, or even active sort of like design solutions, you know, to the client. And the things, this has got to be put sort of like upfront, as early as possible on the onset of a project. And most ideally, it's, you know, having the full team on board. And of course, you know, like Andy did mention with regards to the CapEx, the initial sort of like capital expenditure. But the things that, you know, if you do work out sort of like, you know, the initial sort of like capital injection, and then the things that the energy savings, or the, you know, the water savings that you gain through the kit that you have, you know, you could potentially, you know, have a payback period of anywhere between, I don't know, 10 to 15 years. Like one of the projects where I embarked on, China Merchants Bank headquarters in Shanghai, that was quite some years ago. The project has got LEED Gold. The client was meant to be investing another sort of like 2% of additional construction cost. But the thing is that when the cost consultant and the engineers, they worked out the energy, so like consumption by the building, based on a more inferior or standard average sort of MEP kit. You know, they realized that, you know, the payback period is 15 years. And that is a building that they will occupy for the next 50 years. So when you do put forward numbers to clients, I felt that, you know, they will be more than receptive and interested to learn about such solutions that you may have. Yeah.
Thanks, Yi Kyung, for the answer.
Okay, great. Yeah, we have answers from Neil and Yi Kyung from the structural and architectural point of view. Yeah. And let's open the question and answer session. Everyone is encouraged to ask questions here. If you have questions, just please raise your hand and you can just ask directly. Yeah. maybe Pak Frankie would like to ask questions, as he's also a structural engineer.
Yeah, just very interesting, and I totally agree with what Lim Yi Tiong was talking about. As we must promote reusing of existing building. We must promote not just to demolish and build new, but obviously all of this all these older buildings would need to be designed, would need to be checked. I mean, last week we had another, for example, in Indonesia, last week we had a webinar. That was a Professor Wayan, an expert in seismic from ITB, that basically opened up to us, saying that the buildings in Indonesia that was built in the 80s basically designed to a seismic force that was like about maybe 20% or a 25% of what it is required currently. So but we believe that that's the trend that we need to do. I mean, as you mentioned and Niels mentioned, it is very important to preserve material resources. Now, in that view, obviously, the training and the education that we have so far, we have to say, is all about designing new buildings, and we do have while adapting all this existing building to become to be fit for purpose for what it is now, like example for even for the hybrid mode of working in the COVID era. I mean, in that sense, as a designer, both as a structural engineer and architect, what do you think? How do you think the existing engineers, the engineers and the engineers that's to come, what do they need to learn? What does the university, what does the institution needs to do? Maybe be good to hear a perspective from both an architect and an engineer on this side. So that's my question, Pak Habibie.
Okay, thank you. Pak Neil, Pak Yi Tiong.
Sure, I'm happy to go first. I suppose you're right in saying that it's new. It certainly wasn't a module in my day when I was going through university. It was talked about, but at a very, very basic level. I think nowadays people are a lot more aware of it. Kids are a lot more aware going up through school and then into higher level education. And there's certain quotas that are actually enforced by governments for embodied carbon savings to be put forward. Our UK, I suppose, office will be at the leading face of that, where they have, sometimes it's more important some government projects than price, where they put such a high importance on it, and they feel if they're not seen as the ones driving it in the market, that and the market leaders in it, that they can't actually encourage the rest of the industry to follow. So it's certainly been more aware. I think supply chain is another area that is probably underestimated in this. It's how far your materials have to travel before they're used. Timber is often heralded as the be all and end all, but if it has to come from hundreds whatever thousands of kilometers away, it also carries quite a heavy embodied carbon on that as well. What we're looking at a lot of nowadays is modularization, not just for low rise, but high rise as well, even multi-story. When it comes to hotels, student accommodation, often lend themselves where we actually fit out steel modules that are sourced materials locally in key centers, where you've got workforce traveling shorter distances, staying close by, and then all the materials as well when it comes right through to shipping these modules with the TV, tiling, even the furniture in them off to remote sites. South Pacific, we're doing a hotel at the moment and they're actually stacked together. Now, the additional benefit of that is the zero waste component of it as well. So there's no waste materials then going and have to find a way in a landfill in a remote site as well. So it's a holistic view, and it's not just down to slimming down a concrete slab to take more concrete out. I think it's about understanding the whole supply chain and sourcing the materials for these projects as well.
Yeah, and continuing from where Neil was talking about, he was talking about supply chain and materials. I feel that that also leads to technology. It's more and more pertinent and important, for engineers, even architects, to be more in tune and in touch with technology, not just in terms of learning of software, but also in terms of harnessing of data, and how do you then analyze the data. With that, then can you understand how a building or even a bridge or infrastructure works at its optimal performance, or achieve optimal performance. And through exercises as such, you can create benchmarks for different building types, like for office buildings, for retail, for mixed use, for residential, and this then becomes like a feedback loop of creating or designing or engineering buildings in the digital world, having it built, tracking it, harnessing the data, and how this then goes back into a feedback loop into future design, and the things that and how it then could tap into materials that is very, very much associated with transportation, with logistics, how all this then becomes like a seamless loop or chain. That is on technology. And I think that that there's also a greater need and understanding of importance of collaborations. As the construction industry, every sector becomes more and more specialized and specialist in their sector and field. And the more important for us to know who is out there that we can collaborate, connect with, bring onto the table as an offering, to our clients or even to our partners. And to have that understanding of bringing the best team on board, and how this would then have implications, on the financial and the business model that the client may have in mind. I think it's no longer in the past whereby architects are just architects and we are so-called the dreamers and designers. Engineers are just making things work. And in fact, this could be blended as if we could work together as a team. However, the financial model is so important, in the sense that if it doesn't work financially, if it doesn't work in a functional manner, it becomes a white elephant. It becomes a beautiful building, a structurally sound building, but it's not optimized its fullest potential and benefited the users, or even not just the users, but to the people that is living around it.
Okay, thank you. Anything else from engineers and architects? Ibu Herlina from Batam would like to ask question. Pak Wahyono Bintarto from
Not for now, thank you.
Oh, not now. Okay, Pak Wahyono Bintarto, our senior in Civil Engineering College, the Institute of Engineers Indonesia. Silakan Pak Bin.
There is a lady willing to ask a question. A lady before me, please.
Ibu Herlina mau bertanya? Enggak. Kayaknya enggak, Pak.
Yang lain dulu ya.
Oke.
Saya mau
Kalau nggak ada yang bertanya, mungkin saya lagi yang bertanya.
No,
Okay.
not for now. Not for now. Thank you.
Yeah. Okay. As you know that the high-rise buildings, skyscraper buildings, the cost is the cost of investment is very high. Yeah. And for sure that the client is following the proper staging before they come up to the final investment decision. There is one concept introduced called value engineering, where the engineers challenged to provide economic options, come up with the option without sacrificing the quality of the design. They can come up with cost reduction, so then the client would be happy to continue to the financial closure of the project or final investment decision. So how far this approach taken into account or implemented by both BGNE and Gensler? I think that's all my question for the time being.
Sure. So value engineering, I suppose, is our core service that we provide most contractors when we're going in with design and build solutions to projects. We usually do a compliant design and solution, and then we do non-compliant or an alternative solution. And in that, it either has offerings around dollar value when it comes to reduction of materials, or beneficial use of the building to provide advantages to more open space or columnless free zones, or safety and program as well as our big drivers we find nowadays in our alternative solutions, depending on what I suppose the project's key pressure points are. If it's within budget, some other things come into play, like program and maybe brought to the front. So that's where we focus a lot of our time, is having, you can see from the examples today, is multiple work fronts and zones and challenging that. And this is where BIM comes into another very useful purpose as well, where it's called 4D, which is the staging process. So you model your building, then you'll actually bring in your crane movements and even model your truck, your laydowns. All that can be modeled in, and the contractor can get a very clear overview of the programs, the clash points, and the critical path, all visually, and communicate that to his whole team within a very short amount of time through any of the 4D animations. So that again then facilitates some value engineering options for us, whether you go with a top-down construction, so then you can start from ground level building up, as well as have plunge columns and excavating below in the basement going at the same time. And we've often done that. Or where we have you've heard of obviously jump forming lift cores. What is common now, we've developed technology in the Middle East that we've brought into Europe, which is jump forming an entire building footprint. And with that, especially in very congested city environments, it works well, where the materials can be loaded onto the deck of the entire jump form, and the columns, the walls, everything is brought up in one. You can then skip by very complex transfloor levels that would have, say, gardens, swimming pools, common areas for apartments, and continue up so it doesn't affect your overall program. And then you can go back and visit that and work below the jump form and include all the complexities in those type of slabs without having a heavy impact on the program. So yeah, value engineering is something absolutely. It used to be just, can you make the beam shallower or the less reinforcing in the slab? But it's so much more now, and everybody's so I suppose time focused, and we find it more program driven than materials driven. Not to say that's not an important part of it, but program driven and working with contractors. For example, the Key Quarter project, we won that with the contractor because he was able to stand by his very ambitious program. And from that then spawned all the 4D modeling and the staging and sequencing that really drove and pushed us to our limits as well, to be able to achieve that.
Yeah, and the things that is what you mentioned is covered quite a lot, touching on technology using BEAM, modularization, materials. Just add to what Neil has highlighted. It's like it's all this does help in potentially speeding up the process of work on site, or even sort of like better managing the quality of works on site. And the things that, of course, the sooner the project completes construction, the sooner it can open up, and that in fact feeds back to its financial model. And the things that Pak Habibie, we were talking about the relevance of high-rise towers. I think that in cities, it is nevertheless sort of like it will still have its relevance. Maybe not the super or mega high-rise. Once it hits a certain sort of like height, the cost of the structure and sort of like MEP equipment totally outweighs the efficiencies of the building, like be it efficiencies of the floor plate, etc. I think it's a very delicate balance, and many a times it needs to be assessed at times from a financial perspective, by the developers that's embarking on those projects. But one example that I've came across, which was a Landmark 81 project, where I was a project director on the project in Ho Chi Minh City, is a 461-meter tall tower. The efficiency of the building in terms of floor plate efficiency was only 60+% efficient. The client knew that it is not going to be an efficient building. They originally had in mind that they wanted office, hotel, service apartment, and retail. Eventually, they decided to forego the office component because it is just not efficient enough a floor plate. So they replace the offices with residential units for sale, and then that helped in their capital balancing. They had a few more floors of hospitality because they want to maintain and hold that. They have a bit more area for retail, but then that helps them in their financial model. And the things that through that, what they did too was that it is not, if you look at Landmark 81 project, besides the standalone tower, there is about 20 residential blocks around the Landmark 81. They all belong to the same client. And for those residential developments, they had a markup of 25 to 30% higher in terms of sales per unit square meter, so like rate cost, as compared to any other development around it or near it. The client is literally making back his money that he's invested in this super high-rise tower through the residential developments around it. And it goes back to business, it goes back to the financial model and how they assess the value. But of course, it's like, it also does depend on the value of land in the city. In the heart of the city, of course, if the value of land is extremely high and you're given the opportunity to pull out, the height of the tower, increasing GFA, increasing your revenue through rent or through sales, it goes back to balancing of costs.
Okay, thank you for the answers, Engineer Neil and Architect Itiong. Pak Bin?
Yeah, thank you.
Silakan, Pak.
Yeah, I like to raise question to Pak Nilgan. What is your opinion on the effectiveness of structures using building disassembly as a method of construction for future changes, and dismantlement? Thank you.
Disassembly, is this designing them so they can be possibly disassembled in the future and repurposed, is it?
Yeah.
Ah, okay, okay. Yeah, because that's the, I suppose, the mechanical engineering coming into the structural engineering and developing new jointing techniques, and who pays for that that IP and that intellectual development and property, and what standards do you use to design it to? So, I mean, if you're the first to go, you'd be putting in a huge amount of investment, I suppose, to develop that type of detailing in a structure, with a very, very long, I suppose, wait to realize the value in that later on, because I imagine disassembly would be more of a long term, or are you thinking more of short term structures for events, or housing shortages, or school accommodating big school growth populations? That's where I suppose modules come into play, in that it's not just the individual elements that it's broken down into, that it's actually broken down into, like for the example of the student accommodation we do, we'll have a bathroom pod and bedroom balcony unit. And what we did in the building we built was, they were expecting a massive surge in the student population of a number of years, but they didn't know whether it would be sustained. And what we did was, we did come up with a steel modular solution for them that enabled them to be able to cater for this sudden growth, because they wanted to do it over the summer months almost for the next term. We weren't able to achieve all or accommodate all their students, but we were certainly able to achieve some in that short period of time. And then what we've been able to do is repurpose them in some of their other campuses then as well, and they've seen some large intake and a shortage of student accommodation in the surrounding areas. That would be more medium term. Short term, we certainly do it in mining camps, or mining villages as they're known in Western Australia. Now, these aren't 10 or 20 guys. Some of these villages run into 6,000 or 8,000 people, that even require a police station once you get to a certain population. And in those, this would be driven by the likes of Chevron and BHP of the world, where they need their mining crew to come in. And we'd provide modularized 2-story accommodation that can even handle cyclonic loads. Because obviously it's very cyclone active all around the northwest of Australia, where you find a lot of these mines dotted along, because that's where you find the richest iron ore. But for those, that would be short-term de-assembly, or I suppose modularization. And the benefit of them is, the way we construct them is, we have a screw pile system that the modular accommodation get dropped down on, clamped into. Then when the mining moves, say the mine site will move between 20, 30 kilometers further inland or down the coast, we'll actually move all the construction workers and village along with them, and maybe even relocate the airstrip as well. So that's more of a short-term application. So it's something that happens at the moment, but it involves a very high level of investment at the start to make sure that it's suitable for transportation on trucks, and that the bolting mechanisms are accessible and not prone to corrosion as well when you move them in 5, 10, 15 years time as well. So yeah, they'd be the applications that I can think of off the top of my head that we're already employing in that area.
Fantastic. Thank you, Neil.
No problem.
Thank you, Neil. So any questions? We have one question in the chat room from Pak Ronald for Pak Neil. Please describe applied earthquake return period in your building design. I think Singapore, Australia has different seismic code.
Singapore has no earthquakes or wind to speak of, but Australia does have earthquake requirements. So does the Middle East, interestingly enough. New Zealand would be the most, I suppose, the highest earthquake forces what we have to deal with. In New Zealand, we joke we designed the building for horizontal forces before vertical forces first, because the forces are actually that high. Earthquake return periods are based on the average time between a major event. So like in Australia and Singapore, we'd have a 50-year design life, and over those 50 years, then what's the expectation to see a major catastrophic event? For the likes of infrastructure for bridges, they'd have a 100-year design life. So they'd actually be more, a higher factor would be applied because the chances would be significantly greater of seeing or living through one of those events. How the return periods provided, I suppose, the shorter the return period, the less likely the event and the factors reduced. Typically, we've return periods for 50-year building, depending on its importance level. A hospital would be importance level 4 in Australia, whereas a shed out the back would be importance level 1. So that plays into the return period as well. So say an importance level 2 structure, which just be, say, a residential property or house, that would have a return period of 1 in 250. And as a result of that, then you apply every earthquake has obviously a wave, but every structure has a natural frequency. So the last thing you want to do is the natural frequency to match the wave. It will shake itself apart. The taller the building, interestingly enough, it actually moves and absorbs the energy. It's a much more gentler experience for high-rise earthquake. Wind is actually the big driver for that. Short buildings between 3 and 6 stories are actually the ones that suffer the most in earthquakes. And I know Indonesia has quite a high seismic zone and forces to deal with there. So they be the main structures to be very cautious of, that you have what we call ductile failures, which is forming plastic hinges in the beam elements rather than the columns. So what you do is you make the columns strong enough to take the force and make the beam slightly weaker. So you develop a hinge just beside the column section, and then you get basically a failure, a ductile failure, which is your reinforcement yielding, your steel reinforcement yielding, rather than an explosive failure, like your concrete exploding underneath the compression load. And that's how you design for high seismic zones, I suppose. I'm not sure if that answers the question.
Yeah, I think that answers the question, yeah. Otherwise, Pak Ronald will raise his hand. Okay, let's go to the next question. Either Pak Dedi or Dr. Ayudin. They are both structural engineer.
Okay. Thank you very much, Pak Habibie Rasad. I'm sorry, I can't open the camera because I'm talking the car on a trip.
Ya, silakan Pak.
Okay, high-rise buildings are very complex buildings. I know that. My question, how do you anticipate the influence of lateral force in the presence of wind loads? The taller the building, the higher the lateral force. Then, how do you consider buckling in a column due to tall buildings, and how to consider earthquake force that occur? I think my questions. Thank you, Pak Habibie Rasad.
Yeah, 3 questions at one time. Yeah.
Sure. The buckling of the columns, effectively you design a column between restraints. So the effective length of the column still doesn't change no matter how high the building is. It's driven by the distance between floors. So for the buckling in the columns, we can handle that through, although the forces get very high, well, still, even if you're sailing through 3 or 4 stories, you'll only have a column that's a maximum 10, 12 meters tall. And that's how you'll design it over that buckling length, and you'll have continuity then above and below. And we don't design it for the full height of the building. Earthquake, as I said, isn't a major concern for us. It's something that we check, but it's not a major driver in high-rise design, because the natural frequency of a very tall building enables it to dissipate an awful lot of energy when it comes to earthquake design. And wind design is a massive factor, and not just to do with the ultimate strength, like referring to the buckling of columns. It will drive the comfort for the occupants as well, which has been a massive factor. And we've been called in to help assist with buildings that actually the dampeners weren't either designed out and needed to go back in, or weren't effective enough as well. And you'll find that office workers actually feel a little bit seasick or motion sickness from gentle movements during, and it doesn't have to be major wind events, if it's not designed correctly to cater for them. So yes, wind, we'd always recommend, especially with a high-rise building, that a wind modeling study is carried out in a wind tunnel, because sometimes, especially in areas of high density of high-rise buildings, you'll get funneling effects from the surrounding buildings. They'll actually create peak wind pressures and intensities as well. And then you can use them, the loads and information you get from that modeling, then to assist with the design of the cladding and the building. And a lot of the times you'll actually even find it provides efficiencies in pressures in areas that you found actually don't attract as much load as you would on a basic open book analysis. And I'm not sure, what was the third question?
Pertanyaan ketiga apa, Pak? Pak Yudin?
Masih bisa, Pak? Ya. Okay, thank you very much for explanation.
Thank you.
In the siding and drawing buildings, we are often faced with the problem of calculating how large the size of the columns and the beams are needed to support the space we have designed, especially if a multi-story building that definitely has a floor load, so that is it's heavier. How to anticipate the weight of the building, especially of the wall of the building? Thank you. I need your explanation, sir.
Sure, sure. So I think what you're asking about, the load takedowns, the methods we use to calculate the forces in our members. So we always do a traditional load takedown, which is based on just area thickness, which gives you a volume against the material. And then we also model nowadays a lot in ETABS. And ETABS then provides us with we put in wind and earthquake analysis, and it will actually calculate the natural frequency of the building as well. And we'll use that information and that model then as output to give us all the columns, beams, slabs, foundation and wall loading. And that would be the most common tool we'd use in high-rise design.
Yeah, I think that's quite common to use the ETABS software for structural
Certainly.
calculations also here in Indonesia. Yeah. Am I correct, Dr. Ayudin?
Yes, thank you, Pak Abid.
Yeah, okay.
Thank you.
Thank you. Thank you. Very nice questions and answers. Anyone who has question? Pak Dedi, I would like to encourage you ask questions directly without having a room chat. Yeah. Question, yeah. So please open your camera and ask question. Sorry. Pak Dedi. Pak Dedi. Okay, Pak Dedi is just too shy. Afternoon, Pak Nel. I want to ask about what method do you use in earthquake analysis? Whether you use pushover method as well, or just equivalent static and response spectrum? Wow, this is related to static equivalent and non-linear analysis. And I want to know about wind tunnel for building. Can you describe? Because I just used static load for the design from ETABS.
Sure, sure. Okay, well, I'll address the first one about pushover. method or equivalent static and response spectrum. We use for our high-rise design the equivalent static and response spectrum analysis. A pushover, we might do a high-level hand calc just for some reassurance around the footing design, but it's always generally equivalent static and response spectrum. On the static load equivalent for the wind test, when I was referring to the wind tunneling actually involves building a scale model and putting sensors at key areas on the scale model and giving that to, or your wind consultant will actually bring that to one of their testing facilities, and they'll run a range of wind speeds over the model, and they'll give you they'll obviously have a scaled down version of the equivalent wind pressures, and they'll give you a full report then on the actual pressures given the geometry. Nowadays, it's very unusual just to do a square or a circular building, which the codes are generally written for. You'll get areas of higher pressures and suctions when you've got unusual geometry, as I was saying, especially around other high-rise buildings. It can change the airflow significantly. So when I was saying, about wind tunnel testing, that's what I was referring to, actually physical testing of it. I mean, if you can't do that, not every project we do that for. A course, you can use using the static equivalent load testing for ETABS, which will just use basically code-based application for calculating your wind, and then that will apply it horizontally at each of your floor levels to calculate then your overall forces in your core. And there's nothing wrong with that. It's just I suppose a more rudimentary approach, and we find on especially super tall, mega tall, you'll always have a wind tunnel test carried out.
Okay, Pak Dedi.
Okay, thank you, Pak Neil. But every your project using wind tunnel or no?
The project presented here today, all of them had wind tunneling testing done. Even though it wasn't super tall for the Opus, that opening through the center of the building, we all needed to know exactly how that would behave and how the impact that would have on the comfort for the occupants as well. So yeah, all three of those buildings had testing carried out.
Okay, thank you, Pak Neil.
Yeah, great. When the COVID is over, I think Pak Neil will be visiting us in Jakarta. So
I look forward to it.
More coffee time discussion, yeah. Coffee session rather than webinar is quite limited for us. The timing is so short. Anyway, Pak Fardi, the question from Pak Fardi, I want to ask about the use of pushover analysis, if the calculation apply in soil embankment or soft soil. Hopefully I translate the question correctly.
Yeah, that sounds like another one for me. So when you're doing your pushover analysis, this is generally to do with the overall static stability of the building rather than the core strength and designing for bending. If you're in a soft soil, you will need to model your soft soil system with the springs. And the spring system then has to reflect the settlement that it will achieve, because it'll have a very low bearing capacity. So that would be totally unsuitable for what we're talking about today, which is high-rise buildings. You'd have either a piled raft or a pile and pile cap solution to build in a soft soil.
Okay, thank you. Hope the question has been answered. Pak Farid, yeah. Okay. Okay, guys. I think we have only 2.5 hours session for this webinar, and truly apologize that we have to close the question and answer session and move to the next session, which is the reading of the recommendation obtained from 2 previous webinars, which is related to the professional engineer practice and the role of PE in earthquake emergency and disaster preparedness. So in this regard, would like to ask Pak Frankie, Engineer Frankie Ken, to read the recommendation, just to show us the result of the discussion we have in these 2 previous webinars. Terima kasih Pak, silakan.
Ya, terima kasih Pak Habibie. I apologize first for Neil and Itiong that I'm going to deliver this in Indonesian and for other English-speaking audience. Jadi saya diminta oleh Pak Habibie dan Pak Prastiwo untuk menyampaikan rekomendasi berdasarkan hasil webinar mengenai praktik PE Professional Engineer yang sudah kita lakukan 2 pada tanggal 29 September dan 27 Oktober dan diorganised oleh PII Cabang Batam. Jadi secara umum kami menghadirkan pembicara terkemuka yang nanti ditunjukkan dari dalam dan luar negeri. Kehadiran cukup baik, sangat baik, lebih dari 60 peserta berbayar yang mengikuti webinar, juga disiarkan secara langsung melalui YouTube yang juga disaksikan sama seperti dengan webinar ini. Terlihat antusiasme yang tinggi dari pertanyaan-pertanyaan yang kritis, sama seperti dengan webinar yang hari ini dari hadirin pada webinar. Dan berdasarkan dari pemantauan 1 bulan terakhir terjadi peningkatan minat dan perhatian yang nyata dan terukur terhadap keanggotaan di PII, sertifikat insinyur profesional, STRI, sertifikat tanda registrasi insinyur, dan bahkan undang-undangnya sendiri, Undang-Undang Nomor 11 Tahun 2014. Jadi webinar tanggal 29 itu kita temanya PE Practice in Indonesia and Overseas Benchmarking. Ada 4 pembicara, 3 dari luar negeri, 1 dari Indonesia. Dan di sini kami mencoba merangkum pesan-pesan utama dari pembicara. Jadi pesan utamanya ini bahkan bukan cuma dari slide yang mereka tunjukkan, tapi bahkan dari interaksi seperti tadi dibilang banyak pertanyaan dan speaker kita dengan baiknya merespon, dan itu yang bahkan menjadi lebih esensial karena banyaknya pertanyaan dari peserta. Jadi dari yang pertama pembicara di webinar 29 September adalah Profesor Chiu Sing Ping, Director of Engineering di Singapore Institute of Technology. Beliau ini juga dulunya adalah salah satu member dari PE Board di Singapura dan sekarang pun masih aktif menjadi advisor di pemerintahan Singapura mengenai PE practice. Jadi pesan utama dari Prof. Chiu sendiri, di Singapura dan negara maju lainnya, penyediaan jasa PE merupakan kegiatan yang harus diregulasi. Karena menyangkut bukan cuma kualifikasi, tapi juga perilaku setiap PE tersebut. Jadi ditekankan oleh Prof. Chiu bahwa perilakunya juga penting, etiknya, demi keamanan dan kenyamanan publik secara luas. Terus our own Insinyur Bambang Guritno sebagai ketua dari BK Sipil PII menjawab Prof. Chiu tersebut bahwa Indonesia sebenarnya telah memiliki perangkat yang lengkap untuk pelaksanaan praktik professional engineer di bawah payung UU Undang-Undang Nomor 11 2014 dan sertifikasi PE yang diberikan oleh BKSP PII bahkan diakui dan setara di tingkat internasional. Dan perangkatnya pun lengkap hingga sampai sudah ada desain seal-nya dan bahkan handbook praktik PE Badan Kejuruan Sipil. Dan yang mungkin saya tambahkan di sini sebenarnya manusianya pun jauh lebih juga siap juga ya. Jadi perangkatnya ada dan manusianya ada. Yang berikutnya dari webinar 29 September tersebut, arsitek Angeline Chan yang merupakan chairman DP Architect dari Singapura bahkan berpartisipasi dan meluangkan waktunya ya. Dia DP Architect ini adalah salah satu praktik arsitek dan rekayasa teknik multidisiplin terbesar di Asia Tenggara. Jadi beliau bahkan duduk dari mulai sampai akhir webinar tersebut dan menjawab pertanyaan. Dia menginformasikan bahwa DP Group menginstitusikan persyaratan dan penghargaan terhadap staf insinyurnya untuk mencapai kualifikasi dan sertifikasi PE. Jadi karena sudah ada aturannya, manusianya ada, maka diinstitusikan sebagai korporat. Strategi DP Group ini tidak hanya dalam rangka pemenuhan kewajiban korporat mendukung pemerintah Singapura senantiasa meningkatkan kualitas industri konstruksinya, tapi juga untuk mendapatkan pengakuan dari negara-negara maju lainnya untuk bekerja sama dengan DP Group. Yang kita tahu DP Group banyak juga proyeknya di Indonesia. Dan terakhir ini untuk pada tanggal 29 September itu kita menutup webinar tersebut dengan pengalaman yang sangat personal dari Sasa Popovic. Beliau ini direktur dari Whitby Wood Popovic yang headquarternya di UK, tapi dia residing di Belgrade. Beliau ini mempunyai sertifikasi PE di empat negara, sehingga bisa melakukan sudah memimpin proyek di 4 benua. Jadi beliau ini sangat apa ya, gencar sekali untuk mendapatkan registrasi PE-nya dimanapun dia bekerja. Dan salah satu pesannya dan yang juga seperti kita dengar dari webinar hari ini, persyaratan PE akan terus diperlukan dan senantiasa berevolusi seiring semakin kompleksnya permasalahan dunia dan industri konstruksi. Yang tadi sempat dijawab oleh Pak Neil Gunn sama Pak Lee Mi Tiong ya. Dan dia secara personal pada webinar tersebut mendorong semua insinyur Indonesia yang telah memenuhi persyaratan untuk segera mendaftarkan diri sebagai PE dan menjalankan continuous professional development. Jadi semua ini sebenarnya direkam dan ada di YouTube ya. Ini presentasi dari Prof. Chu, sengaja kita tunjukkan fungsi dari PE Board di Singapura dan kenapa. Nah, di sini disebutkan apakah suaranya kedengaran ya, Pak Habibie?
Kedengaran, Pak, kedengaran.
Mungkin sebentar.
Ya. Suaranya kedengaran.
So the government departments, the building departments, for example, the plans, the structural plans, for example, or other government departments, if it's not submitted by a professional engineer registered with the Professional Engineers Board, they will be rejected. So only registered professional engineers with valid practicing certificates can provide professional engineering services. Right? What are the
Mungkin kita lanjut ke webinar yang kedua, itu pada tanggal 27 Oktober, jadi baru minggu lalu. Temanya di sini agak mendetail dan relevan di Indonesia. Jadi role of PE in earthquake emergency, disaster preparedness, response and recovery. Jadi kembali ada 4 speaker di sini, 3 dari luar, 1 dari Indonesia. Jadi pesan-pesan utama dari pembicara, Dr. Kit Miyamoto ini adalah termasuk chairman dari California Seismic Safety Commission. Jadi tempat seismic code modern ya, rumahnya di sana. Jadi pesan dari Dr. Kit adalah di California sejak 1975, PE merupakan organ utama untuk melakukan dalam kesiapan dan respon terhadap bencana gempa. Nah, di sini bahwa role PE itu bukan cuma ngecat gambar, ngedesain itu, tapi juga melakukan survei bangunan existing, bahkan hingga melatih insinyur-insinyur pelaksana, train the trainer. Dan PE diharuskan ada dalam komite keamanan gempa, baik di sektor swasta maupun kritikal. Jadi salah satu pesannya di sini itu professional engineering itu masih kental ke apprenticeship-nya. Jadi ilmunya itu di-pass on dari satu orang ke generasi berikutnya. Dan PE menyediakan channel PE dengan adanya sistem PE ini itu menjadi lebih terinstitusi. Pembicara kedua adalah Liva Shrestha dari Kathmandu, Nepal. Beliau ini memimpin proyek retrofit lebih dari 1.000 rumah di Nepal setelah gempa Gorkha 2015. Dan beliau menekankan pada saat gempa, setelah terjadi gempa, itu tiba-tiba PE-nya itu tiba-tiba diperlukan sangat banyak dengan sangat cepat dalam skala masif. Jadi di sana mereka mengembangkan sistem dalam 5 tahun terakhir bahwa PE yang sudah ada melatih lebih dari 1.500 insinyur-insinyur muda dalam 5 tahun itu untuk dikerahkan untuk melakukan retrofit. Ini dari pengalaman di Kathmandu. Dan pesan dari Profesor Wayan Senggara yang pastinya tidak asing buat kita semua ya, bahwa hampir seluruh wilayah, pulau, dan kota-kota di Indonesia terancam bencana gempa. Indonesia telah memiliki standar bangunan tahan gempa modern, di mana kekuatan gempa yang ada di standar sekarang itu jauh meningkat dari standar gempa tahun 80-an. Pertama kali standar gempa Indonesia dikeluarkan. Jadi, nah standar gempa bangunan ini, karena Indonesia yang sangat luas, ini harus didiseminasikan dan diaplikasikan dengan ujung tombaknya ya PE di Indonesia. Dan terakhir dari Julia Radcliffe, beliau ini adalah Vice Chairman dari Humanitarian and International Development Panel di Institute of Structural Engineers di UK. Yang di UK itu nggak ada gempa, tapi mereka membuat framework untuk chartered engineer yang ada yang diregistrasi oleh ISTRAC-E apabila mereka bekerja dalam konteks penanggulangan bencana, termasuk bencana gempa. Jadi ISTRAC-E dari UK membuat kerangka kerja untuk PE yang bekerja dalam sektor kemanusiaan dan international development, termasuk tanggapan terhadap gempa. Dan mereka ISTRAC-E membuat framework tersebut atas permintaan dan feedback dari anggota-anggotanya justru. Karena sebenarnya di UK nggak ada gempa. Yang membutuhkan panduan kode etik dan praktik ketika mereka bekerja dalam lingkungan yang seringkali berbeda dengan konteks, kondisi, dan konteks tempat mereka terbiasa bekerja. Jadi ini sangat menarik, karena saya kebetulan juga anggota panel ini, dan di UK nggak ada gempa, jadi banyak yang nanya, ngapain dibikin? Nah ini jawaban dari mereka. Kembali lagi untuk ini sebenarnya ada, dan ini saya langsung ke bagian dari Prof. Wayan. Jadi yang tahun 83 itu return period itu gempanya yang diukur cuma 200 tahun, sementara sekarang 2.475 tahun. Ya. Dan saya kebetulan sempat melakukan di Palu, ya kelihatan memang masih didesain dengan mungkin standar gempa tahun 80-an. Jadi kesimpulan dari 2 webinar tersebut, Indonesia telah memiliki perangkat lengkap dan setara internasional untuk praktik PI di bawah payung Undang-Undang Nomor 11 tahun 2014. Dan mungkin saya tambahkan bahwa manusianya pun sebenarnya siap ya, dan banyak bekerja di luar negeri. Bahkan DP Angelin Chan waktu itu bilang sekitar 20% workforce mereka itu dari Indonesia sebenarnya di DP Group itu. Sertifikasi PI bukan hanya bukti kompetensi, tapi juga pengikatan perilaku PI sesuai kode etik berstandar internasional. Jadi ada standar edukasinya, standar etiknya. Fakta bahwa banyak pulau dan kota di Indonesia yang rawan bencana meningkatkan urgensi supply insinyur tersertifikasi PI. Dan ini sebenarnya PII sudah sangat gencar melakukannya dan diharapkan bertambah gencar di hari-hari mendatang. Dan ini mungkin permintaan kami, pemerintah dan PII harus merespon aspirasi insinyur-insinyur Indonesia, terutama dalam hal pelaksanaan Undang-Undang Nomor 11 2014 dan Peraturan Pemerintah Nomor 25 Tahun 2019 dalam hal peningkatan kualitas layanan keinsinyuran di Indonesia. Jadi ini benar-benar permintaan semua insinyur di Indonesia yang jumlahnya ratusan ribu, mungkin puluhan ribu lah. untuk seenggaknya direkognisi karena undang-undangnya sudah ada. Dan dari 2 webinar terakhir terindikasi secara nyata keinginan insinyur-insinyur Indonesia untuk bergabung dengan PII dan mendapatkan sertifikasi. Insinyur profesional yang berpraktik keinsinyuran yang bekerja di perusahaan kontraktor dan konsultan sesuai dengan engineering law seperti di Kanada mesti mendapatkan PII, professional, ini bukan PII itu, tapi PII, Professional Indemnity Insurance, yang disediakan oleh perusahaan tempat mereka bekerja. Saya kebetulan terlibat dengan satu proyek oleh USAID, dan di sini kita temukan sebenarnya di Indonesia itu tidak ada asuransi untuk yang ini. Nah, ini yang menjadi salah satu masalah utama. Bagaimana untuk siapa yang membayar perkuatan bangunan, perbaikan bangunan, segala macam. Insinyur yang bekerja individual juga diminta untuk melengkapi dirinya dengan PII, dengan insurance tadi, untuk berpraktik keinsinyuran di Indonesia. Sama halnya seperti yang dilakukan di US, di Singapura, dan di Kanada. Sebagai catatan, ini bahkan dari Sasa Popovich, karena beliau terregistrasi sebagai PI di British Columbia, Kanada. EGBC itu seperti PII-nya British Columbia, Provinsi British Columbia di Kanada. Mereka bahkan merencanakan untuk menyediakan dan menawarkan PII, insurance, individual, untuk semua PI yang diregistrasi oleh EGBC. Jadi mungkin ini bisa bahkan menjadi pertimbangan dari PII ya, untuk menyediakan PII, individual. Dan pelaksanaan continuous CPD disarankan dilakukan secara konsekuen sesuai dengan bahkan diamanahkan di Undang-Undang Nomor 11 Tahun 2014. Karena undang-undang kita itu ditulis berdasarkan benchmarking internasional juga. Dan tadi seperti disampaikan dari Itiong dan Nilgan, bahwa kebutuhan sebagai engineering untuk desain itu semakin bertambah kompleks sekarang ini. Ini juga dilakukan di negara seperti UK, Kanada, US untuk insinyur mereka yang sudah terlisensi sebagai PI. Dan pada akhirnya, sebagai catatan akhir, PII akan melanjutkan momentum ini dengan webinar-webinar selanjutnya. Demikian Pak Habibie, terima kasih.
Ya, terima kasih Pak Franky. Thank you, Engineer Franky, for providing the report of 2 previous webinars, which is related to role of PE in disaster preparedness, earthquake emergencies, as well as the PE practice implementation in Indonesia and other countries. That's nice. We'd like also to provide a report for this event and probably giving some recommendations to PII central governance, the governing board, I mean, as well as the government, that we are also quite active in providing a technical webinar related to high-rise buildings from the structural engineering point of view, as well as, of course, architectural point of view. Thus, that I can conclude that we have very exciting webinars. We have architect Itiong Lim, who is the studio director of Gensler. Thank you very much, Itiong, for giving your time, allocating your time, presenting your actually company's capabilities, as well as your professional competency in this high-rise building projects. Pak Nelgan, thank you very much. You have given a lot of knowledge, information to Indonesian engineers who attending this webinar, not only through Zoom platform, but also this is actually a live stream via YouTube. So
I'm famous.
Yeah, it's very famous. You're going to be very, very famous here in Indonesia.
Very good. It was an absolute pleasure. Thanks for having us. I really,
thank you very
enjoyed
much.
sharing them.
Yeah, and last but not least, for sure, Engineer Andi Sanjaya Chong, who has successfully brought Pak Neil and Pak Itiong here to come on board to give us very good insights on this seminar, in this webinar. Okay, before we close the session, Pak Prastiwo, you have something to say?
Yeah, thank you, Engineer Habibi. He was our role model, for engineer, how to become the engineer in Indonesia. This engineer Habibi. Okay, the last but not the least, Mr. Neil, thank you for the great presentation, for this webinar, and also Etiong, thank you. Then we hope all the Indonesia engineers who attend this webinar can absorb all the knowledge. Then later on also can have a further discussion. And as per Pak Frankie said, all the recommendation that have been summary in the last two webinar, including this webinar, we will submit it to the Institute of Engineer Indonesia at the branch at the Jakarta. There is a recommendation for the next the next leader, the president, Mr. Dennis, later on, to have what you call it, code of conduct, how to engineer practice in Indonesia. This is the important things. Okay, thank you, Pak Bibi.
Maybe we can have a photo session before.
Yeah, of course,
gone, yeah.
Yeah.
Yeah, please open up your camera, please. Please.
Yeah, then thank you for Pak Andi as well. Sorry, Pak Bro.
Of course,
thank you,
Pak
Pak Andi.
Andi.
Yeah.
He's always a good friend of us, Nice. Silakan Pak, buka kamera. Pak Imam, can you take photo, Pak?
Okay, Pak. Okay. Slide 1. 1, 2, 3. Okay. Move to slide 2. 1, 2, 3. Okay, thank you.
Thank you, Pak Imam. Okay, thanks everyone. See you in the next webinar session. Yeah. Thank you.
Thank you everyone.
Terima kasih
Thank you.
Pak Itiong, Pak Neil.
Thank you.
Pak Andi Chong, Pak Frankie, Pak Prastiwo, kawan-kawan semua.
Terima kasih, Pak.
Terima kasih.